In this video, I will show you how to interpret a Venn diagram and determine the size or probability of a certain set. So let's start off with this scenario. We have 32 students who were asked about movies they've seen. 20 students have seen Star Wars, 8 students have seen Endgame, and 3 students have seen both. Okay, so we will let set S represent the students who have seen Star Wars, and set E will represent students who have seen Endgame. So first of all, we need to explain what's wrong with this Venn diagram. Well, let's see. I see where they're getting the 20, the 3, and the 8 from, because right here it says 20 students have seen Star Wars, there's your 20, 8 students have seen Endgame, there's 8, and 3 students have seen both, and there's the 3 right in the middle. So what is wrong with this? Well, the problem is, according to this diagram, these are the students who have seen Star Wars, 23. But only 20 students have seen Star Wars, so this is wrong. Or if I look at it from the Endgame side, according to this diagram, 11 students have seen Endgame, but instead of only 8. So let's see. So the problem is they are double counting the middle part, the overlapping part. The 20 students have seen Star Wars. That includes the 3 students who have seen both. All right, the 3 students that have seen both are already included in the 20. So by writing 20 and then writing 3 again, you're really counting the students who have seen both movies. You're counting those students twice, and that's the problem. So since 20 students have seen Star Wars, but 3 of those have also seen Endgame, then there are 17 students who have only seen Star Wars. In other words, look, we know that there are 3 students who have seen both movies. Since there are a total of 20 students who have seen Star Wars, that leaves 17 in this part of the Venn diagram for a total of 20. Similarly, since 8 students have seen Endgame, but 3 of those have also seen Star Wars, that leaves 5 students who have only seen Endgame. So there should be 5 in this part of the Venn diagram, because that leaves a total of 8 for Endgame. Now, we also need to include a number on the outside here representing the number of students surveyed who have seen neither movie. So notice that 17 plus 3 plus 5 is 25. So how many does that leave? Well, if we subtract 25, that's going to leave 7. So that means that there are 7 students in this part of the Venn diagram. Okay, for problem number 3, set S represents students who have seen Star Wars. So we will circle that. So as far as the Venn diagram goes, set S is everything inside of this circle. All right, now the size of set S, which is just a whole number, is going to be 20. All right, the 17 and the 3, so that'll be 20. Now, a probability, at its core, probability is always going to be target over total. So in this case, the target is the 20. All right, that's the students who have watched Star Wars. But then for a probability, you need to divide that by the total, which is 32 students. Okay, so it's going to be 20 over 32. And we could reduce that and turn it into a decimal or a fraction if we wanted to, or a percent. But I'm just going to leave it like this. All right, moving on to number 4. This little mark means not S. All right, it's the complement of S, but that means everything that is not S. Now, not S means these are students who have not seen Star Wars. So in the Venn diagram, I would have to shade in everything outside of the S circle. Okay, because these are students who have not seen Star Wars. All right, so that's what the shading should look like. Now the size of not S, all right, these two numbers represent students that have not seen Star Wars, the 5 and the 7, so that's 12. Now the probability of randomly picking a student who has not seen Star Wars is going to be target over total, 12 over 32. Okay, so remember that this symbol means and. So this would be read S and E. So this represents the students that have seen both movies. All right, they've seen Star Wars and Endgame. So these are students that have seen both movies. All right, so of course, Venn diagram wise, we're talking about, hold on, let me be consistent. Venn diagram wise, we're talking about this. All right, now the size, of course, will be 3. Those are the students who saw both movies. That was given to us right in the beginning. And the probability is target over total, so that will be 3 over 32. Okay, now remember this symbol means and. But this symbol means not. So, S and not E. So we need to think of where do these two things overlap. So I think the easiest thing to do is to shade S in one color, like yellow, and we'll shade not E in another color, like blue. So here is S, which I will shade in yellow. And now I'm going to shade not E in blue. So not E is going to be everything that is outside of E. Boom! The blue here represents everything that is not in set E. But this is an AND problem, so that means we are only going to highlight the overlapping part. Now I purposefully used yellow and blue because I knew that the overlapping part would be green. So the green part of this picture is the only part that's really going to be the answer. So I now need to go back and just erase everything and just only have the green part. Alright, so the shading should look like this. I forgot to do the circling part right here, but the Venn diagram will actually help me visualize what we're talking about. So of course, these are students who have seen Star Wars, but they have not seen Endgame, alright? Because we had to do not E. So they've seen Star Wars, but they definitely have not seen Endgame. So let's see. So that's this one. They've seen Star Wars, but not Endgame. All right, what about the size of this? Well, let's just look back at the original picture. and see the 17 that's there. So we know that this will be 17. And of course, then the probability will be 17 out of 32. Okay. This line is another way of saying not something. So let's start with S or E. Okay, if we started with S or E, that would be all of this. All right, S or E is everything that's in here. All right, or means all of both sets. Okay, that's what it would look like. That's what the shading would look like if there was no like line up here, if that didn't exist. All right, S or E. Okay, however, this line means not S or E. So the actual solution has to be everything else. So imagine that I now went through and started shading everything outside of the blue that I just shaded. So you can see the solution is going to be this part right here. All right, and again, looking at the shading on that Venn diagram will help you visualize how I might word this, because students that are out here have not seen either movie. All right, they've seen neither Star Wars nor Endgame. So these are students that have seen neither movie. Now, what's the size of this set? So looking back at our picture, see the 7? That's students that have seen neither movie. So this would be 7, and of course the probability would be 7 out of 32. Okay, here's a new scenario to talk about. 30 students recorded whether they fell into each of these categories. J means they're wearing jeans today. B means they have blonde hair. And G means they are wearing glasses today. So jeans, blonde, glasses. A Venn diagram representing their responses has been provided. Brrr. Is Carla in the set not J and G? Okay, so not J. All right, so first of all, this means and. So if the answer to this is yes, then that means she has to be in both sets. So is Carla in the not J set? No. Carla is inside, here's Carla right here. Carla is inside of set J. So to be inside of not J, then she would have to be out here. So this is false. So I can say, no, Carla is in set J, as you can see. That means she is not in the set not J. All right, what about problem number 9? Is Jenny in the set not J and G? Well, let's focus on the inner part here first of all. All right, the set J and G. That's the intersection, the overlap of set J and G. So here's set J and here's set G. So this is the overlap between those sets. All right, so that means this part right here is the set J and G. Now, this mark on the outside means that we're actually looking for, we're being asked if Jenny is in the set not J and G. In other words, is Jenny outside of the yellow area. And this is another no, because we see that Jenny is inside the set J and G. So that means she's not in the complement of that. She's not in the not J and G set. So again, no. Jenny is in the set J and G, so she's not in the set not J and G. Okay. Is Bob in the set B and G and not J? Okay, well, let's highlight that set and see if Bob is in there. So anytime I have three sets like this, the method I like to use is I'm going to lean on the fact that I know that and is less, or is more, but and is less. Meaning I can start with set B, and then I will erase my way down as I get to the other sets. So let's start with set B. All right, here are all the names that are in set B. I'm just going to highlight all of them. All of these people are in set B. Okay. Now, this is an and problem, so I'm only going to erase names off the list from here. So far I've done this. So now I want to say and set G. So, which of these names are also in set G? So you see circle G over here, and that includes like these names right here in the middle. That means that all of these names that are outside of circle G have to be erased from the list. Okay, so see how this is the overlap between set G and set B. So far I have B and G. Now I need to do and not J. Okay, so look at these four names. Which of these names are not in J? Well, that's Bob. Bob is not in J. Okay? Now, that's a good thing in terms of this target. Not J is what I want. So that means Bob should be highlighted, all right, because Bob is not J, and that's to be included. But that means I have to erase these three because they are inside of J, and we're looking for not J. So Bob is the only person that fits all three of these. So is Bob in the set? Yes. Bob is the only person in the set. So we could say yes, Bob is in the set B, as you can see, and he is in set G, which is right here, and he is not in set J. All right, because here he is outside of set J. So he fit all three of these criteria. For number 11, we are supposed to find the size of the set J and B. That's the overlap of sets J and B. All right, so here's set J and here's set B. So the overlap is right here. All right, these are the people that are in set J and set B. And I see that there are 5 students in that set. So that's the size of J and B. Now, this P means probability. And probability is target, which is the 5, divided by the total. So they told us up front that there are 30 students. All right. So target over total, that's going to be 5 over 30. So that'll be the probability. Okay, and of course I could write that as 1/6 if I wanted to reduce. Okay, look at number 11 and 12 above. How are the questions similar? How are they different? How are your answers similar and different? Well, problem number 11 is asking us for a size, whereas problem number 12 is asking us for a probability. All right, but they are asking how are the questions similar and different. So how are the questions similar? Well, both questions are asking about the set J and B. J and B. So question similarity, both are asking about the set J and B. The question difference is that number 11 is asking for the size of the set, whereas number 12 is asking for the probability. Now let's talk about how the answers are similar and different. And the bottom line is going to be, for problem number 11, the answer is a whole number, whereas for problem number 12, the answer is going to be a fraction or a decimal or a percent. So again, let me be even more specific because they want to know how the answers are similar and how are they different. So first, how are they similar? Well, both answers involve the number 5. So that's the similarity. The difference is in number 11, the answer is just a whole number, just the 5, whereas number 12 is a fraction. Because it was probability, we had to do target over total, so we had the fraction 5/30.